We're continuing on with our trig notes on the pink paper that you picked up. We're looking at that SOHCAHTOA, the SOH, the sine function. So if I look at that S, it means the opposite over the hypotenuse. That's what I'm looking at, that ratio. So the sine function is the ratio of the length of the opposite side to the length of the hypotenuse. If I'm looking at triangle ABC, angle B is my right angle. If I want to find the sine of angle A, the opposite to angle A will be side BC. The hypotenuse is side AC. When I substitute in those lengths, BC has a length of 4, AC has a length of 5, so my ratio is 4 to 5, or 4/5. If I express that as a decimal, it will be 0.8. If I look at the sine of angle C, the opposite side is side BA, which is a length of 3. The hypotenuse is still that length AC, the length of 5, and 3 over 5 becomes my ratio of the sine of angle C. If I express that as a decimal, that will be 0.6. Note you cannot take the sine of a right angle. If I'm looking at triangle XYZ and I'm trying to find the sine of angle Y, I look at the side opposite, which is XW, over the hypotenuse, which is side WY. The XW has a length of 5. The hypotenuse has a length of 13, and my sine of the angle Y will be that fraction 5/13. If I express that as a decimal, it's 0.38. If I look at the sine of angle W, the side opposite is XY. The hypotenuse is still WY. Side XY has a length of 12. My hypotenuse still has the length of 13. 12/13 would be the ratio. If I express that as a decimal, that will be 0.92. The angle that does not have a sine, of course, is my right angle, and in this diagram, that's angle X. If I look at the last example of the sine page, I'm looking at triangle RST. My right angle is at R. If I look at the sine of angle S, I want the opposite side, which is RT, over the hypotenuse, which is ST. The length of RT is 24. The hypotenuse is 25. So my sine of angle S will be the ratio 24 over 25. As a decimal, that's 0.96. If I want the sine of angle T, I want the side opposite, which is RS, over the same hypotenuse of ST. RS has a length of 7. My hypotenuse is still 25. So the sine of angle T will be that fraction, 7 over 25. If I express that as a decimal, it's going to be 0.28. The angle that has no sine is my right angle, which is angle R. If I flip over to the other side where I'm looking at that cosine function, that in the SOHCAHTOA, it's the ka part, that tells me that my cosine equals my adjacent over the hypotenuse. That's C equals A over H. And so the cosine is the ratio of the length of the adjacent side to the length of the hypotenuse. So again, if I'm looking at triangle ABC with my right angle at B, if I'm looking at the cosine of angle A, I want the adjacent side, which is segment BA, over the hypotenuse AC. That gives me the fraction 3/5. And as a decimal, that's 0.60. If I want the cosine of angle C, I want the adjacent side, which is BC, over that hypotenuse AC. That gives me my length of 4/5, and that gives me a decimal approximation of 0.80. Again, note I cannot take the cosine of a right angle. If I'm looking at the practice sessions, if I want the cosine of angle Y, I want the adjacent side, which is my XY, over my hypotenuse, which is my YW. That adjacent side is got a length of 12. My hypotenuse has a length of 13. And that fraction 12/13 is the cosine of angle Y. If I put that as a decimal, it'll give me a 0.92. If I want the cosine of angle W, I want that adjacent side, which is that WX, over my hypotenuse, my YW. My adjacent side has a length of 5. My hypotenuse is still 13. So that fraction 5/13 is the cosine of angle W. If I express that as a decimal, I get 0.38. The angle that has no cosine, again, is my right angle, which is angle X. If I look at the last triangle in the cosine section, I have triangle DEF. So if I want to get the cosine of angle E, I want the side adjacent, which is DE, over the hypotenuse, which is EF. The length of DE is 7, the hypotenuse is 25, and so that fraction 7/25 is my cosine. If I express that as a decimal, I get 0.28. I could also take the cosine of angle F. The cosine of angle F will be that adjacent side, which is DF, over the hypotenuse, which again is EF, and that will give me a length of 24/25. And if I express that as a decimal, I get 0.96. Again, the angle that has no cosine is my right angle, angle D. If I look at my last trig function, that's SOHCAHTOA, the TOA part, reminds me that the T is equal to O over A, opposite over adjacent, and the tangent is the ratio of the length of the side opposite the angle to the length of the side adjacent to the angle. So for the tangent function, I never use the hypotenuse. So if they don't give me a hypotenuse, I'm expecting to use my tangent function. So again, I'm looking at my triangle ABC with my right angle at B. If I want the tangent of angle A, I want the opposite side BC over the adjacent side BA, which gives me a fraction of 4/3, or 1.33. Notice that my tangent is the only trig function that can give me a number bigger than 1. I can have an improper fraction or a decimal bigger than 1. If I want the tangent of angle C, I want my opposite side, BA, over my adjacent side, BC, gives me my fraction of 3/4, or a decimal of 0.75. And again, I can't take the tangent of the right angle B. If I look at triangle XYW, if I want the tangent of angle Y, I want the opposite side, which is my WX, over my adjacent side, which is my XY. The length of WX is 5. The length of XY is 12. 5/12 is my fraction for the tangent of angle Y. As a decimal, that's 0.42. If I look at the tangent of angle W, again, I want the opposite side, which is that XY, over my adjacent side, which is WX, and my fraction will be 12 over 5, which is 2.40. Notice that the tangent of one angle and the tangent of the other angle are flipped or reciprocals of each other. The angle that has no tangent is the right angle, angle X. The last example, we have triangle PQR with my right angle at P. I can take the tangent of angle R. If I'm looking at the tangent of angle R, I want the opposite side, which is PQ, over the adjacent side, which is RP. The length of PQ is 7. The length of RP is 24. And 7 over 24 is my fraction. If I express that as a decimal, I get 0.29. I could take the tangent of angle Q. The opposite side would be side RP. The adjacent side would be that side PQ. So in this case, I'll have the 24 over the 7. And expressed as a decimal, that gives me 3.42. I cannot take the tangent of a right angle, so the angle that has no tangent will be angle P.